Okay, so today we're going to look at congruent chords and arcs. And so our topic would be congruent chords and arcs. And then this is 10-3. So we have a lot of information, a lot of theorems that you're going to have to know. So, whoops. It's going to be vitally important that you study this. So let's fill in some stuff. So 2 chords, and remember that a chord has endpoints on the circle, and it's a straight line. It's part of a secant. So this is a chord. So 2 chords are congruent if and only if the following. Their corresponding arcs are congruent. So, for instance, if this is chord AB, its corresponding arc is arc AB. If this is chord CD, its corresponding arc is arc CD. So, if this arc from A to B is congruent to this arc from C to D, we can now conclude that chord AB is congruent to chord CD. And so we're going to write that out. The measure from A to B, that's what that notation means, is equal to the measure from C to D. And this arrow, if you recall way back in September-ish, means if and only if. If and only if. Yeah. If and only if the measure of arc AB, make sure that's definitely a curve, is equal to the measure of arc CD. And vice versa. So remember that this is an if and only if statement. So if we find that the measures of the chords are equal, we can conclude that the measures of the arcs are equal. If the measures of the arcs are equal, we can conclude that the measures of the chords are equal. So it works forwards and backwards. The converse and the normal statement are true. Yes? No. No. All right, and then the second statement, 2 chords are congruent if and only if they are equidistant from the center. What does that mean? So a distance from the center, so here's the center of the circle, the distance from the center, distance is always perpendicular to a line, right? We learned that also back in first semester. So this distance from E to F represents the distance from the center to that chord. This distance from E to G represents this segment E to G represents the distance that chord CD is from the center. And what it's saying is if these distances are congruent, then the corresponding chords are also congruent. So if these whoops, let's erase that little buddy. I hit the wrong thing. So if these distances here are congruent, then you can conclude that the chords are congruent. So it's a lot of stuff you're going to have to remember. So therefore, AB, the measure from A to B, is exactly equal to the measure from C to D if and only if the measure from E to F, that's that center measurement, is exactly equal to the measure from E to G. And then the third thing that we need to talk about is here, if a diameter or radius, so here's a radius from here to here, and isn't a radius part of a diameter? right? So if a diameter or a radius is perpendicular to a chord, see that right there? Then it bisects this chord. So if it's perpendicular to a chord, this chord right here is going to get bisected. This chord right here is going to get bisected. So that's something that you have to study and remember. So if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So that means the distance from A to N is going to equal the distance from N to B also. So not only does the chord get bisected, but its arc gets bisected as well. There's a lot of stuff that you have to remember. If I were you, I'd be putting these on flashcards. Just a suggestion. And so we get whoops, I don't want that. If segment EH is perpendicular to segment AB. So I'm just using this as an example right here. So if EH is perpendicular to AB, then, so notice it's just one arrow, then the distance from A to F is going to be exactly equal to the distance from F to B, and the measure of arc AH is going to be exactly equal to the measure of arc HB. So we're going to use all of that stuff below, and it can just all be jumbled and put together, and so you're going to find today's homework a little bit more challenging than you found the previous two homeworks. So are you ready? Okay. So I'm not going to do all of them, but I'm going to do several of them. So let's start with number 1. So as you look at number 1, what do you see? What do you see here? We're trying to find x. So what is this telling you? 115, well, if the chords are congruent, aren't their corresponding arcs congruent?
Yeah.
So then all we're going to do to set up our equation to solve is we're going to take 7x plus 24 and set that equal to 115. And then use your algebra to solve. Subtract 24. You get 7x is equal to divide by 7. A lot of you think 91's prime. Is it? Nope. 7 goes into 9 once with 2 left over, and 7 goes into 21 3 times. Does that answer the question? Yep, they're asking for x. So x is 13. Let's move on to 3. So for 3, we're finding, what's this notation asking you to find? Is it an arc or a chord? So from x to y, that's a chord. So they're asking you for the measure from x to y. And what do you notice here? Yeah, so this is just the converse. If the arcs themselves are congruent, what can you conclude about the chords? They're also congruent. So we're just going to set those expressions equal. So 9x minus 34 is exactly equal to 4x plus 1. Use your math. So always collect your x's first. So 4x is smallest, so I'm going to subtract it from both sides. And so I get 5x minus 34 is equal to 1. Add your 34. And we get 5x is equal to 35. Divide by 5. And what do we get? X is equal to 7. Does that answer the question?
No.
No. So they want xy. So this is just step 1. So then step 2, we're going to have to plug and chug, right? So we've got the value, or the expression, for xy is 4x plus 1. So we're going to put the 7 in there. Yep, so we get 28 plus 1, which is 29. Because I'm doing it with you too. They get successively more difficult. All right, so let's look at 5. I just want to expose you to a bunch of different situations. So I want you to discuss with your table group how are you going to solve this one. What do you know? Because this one's not as straightforward as the other two. So what do you see in the picture? What does it tell you? What do you think you can do to help solve the problem? Because we're trying to find x. So chit chat. Everybody talk. Chit chat, guys. Talk about it, guys. Talk about what you see. Yeah. All right, so who has some ideas? Who has an idea? What can we do? What can we do? Tristan, what do you think?
20 to 76,
Say that again.
add 20 to 76 and negative 20.
20 and 70. What are you talking about? 20 and 76. I cannot break the 20 up with the 76. What are these telling you right here? That the chords are congruent. Nathan? So he said subtract 76 from 360 and then divide by 2. So I would prefer to set up an algebraic equation because that's scratch, but I understand where you're coming from. So there's a couple of ways that you could do this. You could subtract the 76 from 360, right? And then shouldn't, if these chords are congruent, aren't their arcs congruent? Well, this arc right here is 6x minus 20. Doesn't that mean that this arc right here is also 6x minus 20? So what I would prefer to see instead is you could either subtract the 76 from 360 and then take this plus that and set it equal to that value. Or you could just take 6x minus 20 plus 6x minus 20. Couldn't you write that as 6x minus 20 times 2 with parentheses? And then distribute the parentheses? You could do that. And then plus 76 equals 360. So that's another way that you could do it. So use your algebra. So we've got 6x and 6x gives us what? 12x. And then we have a minus 20 and a minus 20, which is what? Negative 40 and a positive 76. Positive 36 equals 360. So subtract 36 from 360. What do you get? 324. So I get 12x equals 324. Divide by 12. I get 27. Does that answer the question?
Yeah.
That one does. That one's a little bit more difficult. Jesse? I want to see you using algebra. So if you're going to subtract the 76 from 360, I want to see 2 times 6x minus 20 in parentheses equals whatever that is. 2, whatever. Does that make sense? Then because then you're dividing by 2 and then, you see what I'm saying? I want you to think algebraically and set up those equations because as they get more difficult, if you can't figure out what's the equation that I need to write to solve it, it gets harder. So, all right, so let's look at 6. 6 looks a little different. You notice here and here, what are these telling you?
90-degree angles.
No, this right here.
Congruent arcs.
So if my arcs are congruent, what do you know about the chords? The chords are congruent. And then notice that this is part of a radius, isn't it? And it's perpendicular to that chord, isn't it? Well, it also bisects that chord. So they've given you some information in the directions. They've given you MP. Well, MP is the distance from the chord to the center. We also know from above that if these chords are congruent, aren't they equal distance from the center? Well, they just gave you MP, which is a distance from the center. And PN is also the distance from the center, isn't it? So if the chords are congruent because the arcs are congruent, then those distances that the chords are from the center are also congruent. So it's a complicated looking picture, but a simple solution. So aren't we going to set those equal to each other? So our first step, because this is going to be a multi-step one, is to take 5x minus the 34 and set it equal to 2x minus 4. If I subtract 2x from both sides, because I always want to collect x's, I get 3x minus 34 equals a negative 4. What happens when I add 34 to both sides? What's a negative 4 plus a positive 34?
30.
Positive 30. And then divide by 3. What's x equal to? 10. Does that answer the question? No. So the question says find the measure from m to p. So m to p is here, so we're going to take this value for m to p. And then step 2, we're going to plug in Chug. So we've got 5 times x minus 34. Well, our x is 10. So that gives us 50 minus 34, which is what? So the distance from m to p is what? 16. How could you check your work?
The same thing to PM.
Do the same thing to pn, and you should get the same answer, right? So any questions on that front? Okay, so let's turn it to the back. Okay, I've got 10 minutes. Awesome. Okay, so let's look at 8. So question 8, they want you to find the measure of arc MP. So here's arc MP. What are they telling you right here? Right here, little teeny weeny stuff. What are they telling you there?
It's right
No, right here.
off.
A little tick mark right there. Okay, so the distance that the chord is from the center is congruent on both of these. What do we conclude about the chords? If the distances the chords are from the center are congruent, what do you conclude about the chords? The chords themselves are congruent. And if the chords are congruent, what do you conclude about their corresponding arcs? The arcs are congruent. So we're just going to set 9x minus 43 equal to 5x plus 33. Collect your x's. And we get 4x minus 43 equals 33. Add your 43. And you get 4x is equal to what? 76 trombones in the big parade. Just saying. Divide by 4. What do you get? What do you get? 19. Does that answer the question? No. So we have to go back and find MP. Okay, so this is just step 1. How am I going to find MP?
Out of play.
Don't I have to find what the measures of these are first? And then do what? Subtract them from 360. So let's plug in to which one looks easier? Yeah, I would use that one. 5x plus 33. So we're going to put in 19 That's a 19. Shocking but true. There we go. So 5 times 19 is 95. Plus 33 gives you 128. So arc MN, the measure of arc MN is equal to 128 degrees. So what that gives us is this is 128, this is 128. So take 360 and subtract 128 and subtract 128. What do you get? 104. Does that answer the question? So step 3, the measure of arc MP is equal to 104 degrees. So look at 9. So 9's a busy picture, but let's look at see what the picture is telling us. What is this telling you here? What's congruent? The distance the chords are from the center. So if the chords are equal distance from the center, both of these are, what do you know about the chords? The chords are congruent. And so are their corresponding arcs. You also notice that this distance is part of a radius, correct? If a radius or a part of a distance is perpendicular to a chord, what does that do to the chord? It does what? It bisects it. So I know, and I'm only going to do it on one side of this, I know that this is congruent to this, and it also bisects the corresponding arc. And so the question, they give us a bunch of information. RS is 18, so that's our chord. So if RS is 18, then what's half of 18? So I'm going to put a 9 here and a 9 here. And then the measure of arc TY is 42 degrees. So I'm going to put 42 degrees here. Doesn't that mean that this arc TU is also 42 degrees? Because the arc is bisected as well.
It also is RX, SX is also
42. Very good. So we also know that Rx is 42, and we know that XS is 42. Couldn't I find the arc from R to T if I had to?
Yeah.
Yeah. And so let's look at the questions. So TV, is this asking you for an arc or a chord? Or a length? What's this asking for?
Chord.
So from T to V is only half the chord, right?
It's 9.
So if this is 9 and this is 9, aren't both of these also 9? So TV is 9. What about TU? So TU is all the way across.
18.
It's 18. Very good. What about WS? Well, we already figured that one out, right? 9. And then YU, we already figured that one out, right? That was 42 degrees. And then RS, arc RS,
84.
yeah, 42 plus 42 is 84 degrees. So that's not so bad, right? Moving on down to the bottom of the page. Let's look at 13 and 14. So it says use the circle below for questions 13 and 14. So this is a little different. You've got a chord here with a radius perpendicular to it. So doesn't that radius bisect this chord? Right? And the arc as well. And then, so you've got a little right angle here. Can't we use Pythagoras Theorem knowledge in here? Perhaps. So some of your prior knowledge is going to come back. So the only information we have is that this is 23. And what does that say? 5, right? So we know two sides, the right triangle. So in 13 they want VW. Well, VW is this whole distance. If I let this part be X What do I know about VZ? Right, so isn't VZ also X? So if I find what I've called X, which is from Z to W, don't I just double it to get the answer? Okay, so we're going to use Pythagoras Theorem. So we're going to use a squared plus b squared equals c squared. So we're going to, yes we are. You never get to forget it. All right, so what's my hypotenuse on this triangle? What's my hypotenuse? 13. So 13 has to go here on the right. And then my legs are 5 and x. So I get 5 squared is 25 plus x squared equals, what's 13 squared? 169. What's 169 minus 25? And how do we find x? Take the square root of both sides, right? And so x is 12. Does that answer the question? No. So this was step 1. So then step 2 is to do 12 plus 12, right? So VW is equal to 24. How are we going to find arc YW? Do we have enough information to find YW? Yes or no?
Yeah.
What do we have?
We have VW.
Okay, so this one's a little bit more difficult. So we have now 3 sides to a right triangle, don't we? All I need is this angle right here. Isn't that my central angle from here to here? Agreed? I can find this angle right here because we just did a whole chapter on some old hippie caught another hippie tripping on acid. SOHCAHTOA. Can't we use SOHCAHTOA? And any 2 of these 3 here? I'd rather use the 5 and the 13. Why? Rather than the one we came up with. Why would I rather use the 5 and the 13? Because they gave that to us, right? I might have made a mistake on this. Oh, didn't we make a mistake? Oh no, we didn't. We did. We're good. So I might have made a mistake finding this leg here, right? So I don't want to use that. So let's look at that triangle. I'm going to draw it a little bit bigger here. So we've got the triangle here. Because if I find that central angle, then I have found my arc measure. And so this is the angle I want here, x degrees. So what is the 5 to the x degrees? Is it like opposite, like adjacent, or the hypotenuse? The 5
Adjacent.
is adjacent. And what's the 13? Hypotenuse. So what has an A and an H in it? Cosine. So I know that I'm using cosine. So I've got cosine of x degrees equals, and I've got a ratio here that I'm going to set up with caught another hippie. So my adjacent was 5 and my hippie was 13. How do we, or what do we put into our calculator to find a missing angle? So we do x degrees is equal to the inverse cosine of 5 over 13. So use your calculators. I want you to find that. And what do you get? What'd you get? 67. Let's go out to 2 decimal places. Point what? 38 degrees. And that's the same as our arc measure, YW. So that one's a little harder. So I'm going to go ahead and stop there for today.